Hey everybody, Dave Lindbergh in Hong Kong with another episode of THD Podcast. Today we have Trulli Audio joining us from the Chicago area, talking about their thin driver, perimeter-driven acoustic driver technology. So we're going to find out all about that. And without delay, let's not forget the ALTI Association, the Audio Loudspeaker Technologies International. We encourage people to get out and join that great audio promotion and networking organization. So without delay, let's get into meeting everybody. So we got Jordan Neuhauser, Chief Marketing Officer from Trulli, and Andy Briggs, the Senior Acoustic Engineer, joining us in addition to, always from Japan, Simon Weston. So whoever wants to go first, say hello and introduce yourself.
Great to be with you.
All right.
Okay. Absolutely. Andy, you want to introduce yourself?
Hi, my name's Andy Briggs. I'm the acoustic engineer over here at Trulli. I've been in music for since in high school. I played jazz trombone in high school, playing jazz trombone through college for the most part. But I really kind of got into electronic production in college. I worked with some very small local artists at producing for them in Champaign-Urbana, and then at University of Illinois. And then when I came up here, I kind of worked in manufacturing for a little bit until I came across Trulli. I was acoustic engineer, was my background at school. So finding Trulli and finding that they really needed somebody like me to come in and take over development, really kind of pushed me in that direction. So here I am today, doing driver development for past like 3 years or so. I think I've been here since January of 2020. And yeah, a lot of fun. Cool. So,
all right, Jordan.
Yes. Thank you both for having us. This is exciting. I'm just going to start off by saying I've never done a podcast overseas, so this is pretty cool. But my name is Jordan Neuhauser, Chief Experience and Marketing Officer now at Trulli. That just recently changed. My role at Trulli is to not just understand the market and try to define the market as it is for Trulli, but really connect the customer experience and the internal engineering experience and really bring those worlds together. So it's a pretty cool position that I'm in here. Similar to Andy, I was in that brass section, grew up playing sax, and then migrated from saxophone to turntables. So that was fun. Started as a DJ when I was 14 and then started a DJ company that evolved into an experience and production company. And so from owning, full JBL line arrays to, weekend warrior type speakers to then outfitting myself as a audiophile, my life has revolved around music and the speakers that drive that music. And so it was about 6.5 years ago, Len Foxman, our founder and president, sodded me out and said, "Hey, I want you to take a look at this." And it really just blew me away, the technology that they were working on. And so I had sold my previous company and now have been on this exciting journey. And it's really been fun to work with a group of engineers really that are musically focused, but technically driven, right? And it's a really fun world to be in. So I appreciate y'all having us on, and we're looking forward to talking about our technology.
All right, great. So I guess people are probably chomping at the bit to find out what Trulli's all about. So without delay, let's get into a presentation, if you could share with us.
All right, cool. So here's better photos of Andy and I, in case y'all are wondering what we look like when we're in front of a camera. But we appreciated the introductions from earlier on. So without further ado, jumping into our technology and really our advantage and why we're so excited to be here and really what we're working on. The biggest thing and most obvious thing is the space saving. On the right side of your screen, you can see an angled view of the driver.
Mm-hmm.
So you can start to see the rear, which is not traditional looking.
Right.
You can see that there, and Andy will go into more detail, but that's that perimeter driven. So that voice coils on the perimeter with some beautiful neodymium magnets and this beautiful motor. It looks really nice. And so regardless if you're trying to mount it front facing and you want it to kind of just disappear, and due to the fact that we don't have a cone, it really can blend nice, really seamlessly. Or for those who are more creative or want to show off their acoustic design, inverting the driver is really fun. So just depends what you're trying to do. There's aesthetically pleasing ways to mount the driver. There's also ways to customize the driver depending on various applications. So we know that the automotive application, there's a lot of advantages. The weight, the depth, whether you're going under seat or indoor. Indoor is great because you have to take into consideration when the window rolls down. And so the fact that we're so shallow, you can get a great front stage sound like never before. Or you can choose to increase your low end because of the capabilities as a subwoofer. So Andy will go into more details about the various use cases and why it performs well in all of them. If you're not into automotive upgrades or OEM systems, home theater applications, small room in wall, thinking about 2x4s or the application of just being able to mount something in the existing wall and not have to worry about the depth. That's really powerful. When looking at portable or installed systems, so this is really why my background, and when I say back, it pains me to say that because I did have a spinal fusion. Big speakers kind of hit home for me. And so when I think about how we could not just improve trucking and weight, but even the individuals that have to move these speakers, there's a lot of advantage there. Marine audio, we know space is limited when getting into boating, and it's noisy when on a boat. And so when thinking about how we're able to combat that, there's really cool advantages to our technology there. Museums, house of worship, or architecturally designed homes, like really those specialty, really cared for applications where you need something that's quality, not just loud, but you need it to be quality, just as quality as the atmosphere that you're in. And so we pride ourselves on saying clear and loud because we think it's easier to get loud than it is to be clear and loud. So we put a lot of emphasis on that because we really do focus on not just clarity at low and mid levels, but really pushing it to the full extent. So moving forward, the thin driver has evolved. It started off as a TD-12. It won a CES award in 2015, predating myself. And the challenge, though, was the manufacturability of the TD-12.
Mm-hmm.
It was a really great concept, but it was not manufacturable. And so since then, we've added a couple dozen engineers, including Andy, really focusing not just on the acoustics, but the manufacturability. And so now we have figured out how to scale this technology down to a 38 millimeter driver. We have the 200 millimeter driver that we're going to talk about here today. But the technology scales, and frankly, as it scales larger, our differentiation only becomes that much greater. So without further ado, I'm going to hand the mic over to Andy and let him deep dive more into how the technology has advanced and where we're at today.
All right.
All right, thanks, Jordan. So the first thing, first and foremost, you can see that our coil, voice coil, if you see from the third piece in there, is actually goes around the full perimeter of the diaphragm, which is the second piece in. And what this actually means, the implication of this is we actually have to flip the spider. So the spider is no longer attached to the coil as it normally would be, and then to the top plate, it's flipped. So the spider is inside and attached to the back of the diaphragm and the top of the top plate. We have an array of 16 magnets that make up our motor, 16 neodymium magnets and 52s. And then we have a top plate a low carbon steel top plate that comes on top of that. The coil itself is a single flat wound, or not flat wound, edge wound. Sorry. So it's where the edge, the short edge of the coil is against the former instead of the flat edge of the coil against the former. So it's like this. That actually is able to, with that, we're able to pack more windings in the gap, get a higher sensitivity. And yeah, I think we can move on to the next slide here, Jordan.
Cool.
Yeah. One thing that's really nice about the big coil is it actually keeps our heat super low because we have such a large surface area to get rid of heat. So especially in these new ANC applications in cars that are coming out, low frequency at long periods of time at high power tends to burn out these drivers, the conventional drivers that have a small coil. So the larger coil actually does have an impact there. And we have been able to put it through its paces, like a full 200 watt sweep over and over and over again throughout the night. We woke up the next morning, still fine. So it's pretty durable. The coil's pretty durable.
Andy, can you just expand on that for people watching and particularly myself? Is it the drivers working harder adding cancellation frequencies rather than just music in an ANC application? So it's also sending cancellation frequencies plus the audio, so it's working harder, or what's making it heat up in a normal driver?
I think it's I think mainly this is just coming from some people that we've talked to within the industry that have kind of said this. The way I understand it is road noise in particular is very low frequency cancellation. So you have to combat that with, essentially inverse phase of that. Right. So yeah, for long periods of time, some of these drivers just can't handle it, especially the low cost drivers with the lighter coils.
So it's more about just the lower frequencies trying to be the cancellation waves trying to be sent out by larger and it overworks them. Okay.
Yeah.
It's not your Chicago house music blasting too much.
Well, I mean, it's good for that too.
Right.
So,
okay. Yeah. Sorry. Keep going.
Okay. So we can see some TNS metrics on the thing. We can keep on the screen. One of our main challenges that we have is because we have such a large coil, mass is a problem. We just have to find unconventional ways to pull mass out of our moving mass so we can keep our sensitivity high. And we've done that over the years. So we've gotten to the point where our sensitivity is competing with the rest of the drivers in the market, and in some cases beating them. Our maximum excursion is 9 millimeters, but we can go up to 14 millimeters total of XMEC. And with subwoofers, they tend to go a lot of tuners tend to allow them to go past their maximum excursion range, and they can go past their maximum excursion range and still sound good. So we want to be able to allow for that. And this actually equates to, you don't see it on here, but it equates to an efficiency bandwidth product of something, I think it's like 55 or something like that, which makes us ideal for both sealed and vented applications. So, which is good. And yeah, I think we can move on to the next page here, Jordan.
Cool. And I just want to
Sure.
call out one thing. When you say vented, are you referring to just traditional slot port, or are you saying that this would work in more complex fourth or sixth or eighth order bandpass designs?
Yeah, both. We've actually so we've put it in both vented applications and fourth order applications. And with vented applications, we can easily effectively get down to 20 hertz in a vented application, which is really good. And that's a true 20 hertz. That's not like a fake 20 hertz. That's some systems tend to use DSP tricks in order to make it sound like you're getting a 20 hertz when you're not actually getting the 20 hertz. Yeah, so we have done it in a vented application, and we have seen desirable results. And then the fourth order application, we have some really interesting things on the horizon with fourth order. But even without that, we have tried it, and we can get this really massive 50 hertz peak. That sounds really good in a vehicle. So we're really happy about that. We're really excited about that. So
cool. Mm-hmm. Thanks, Andy.
Mm-hmm. No problem. So yeah, so we actually have some testing capabilities in house, but we do utilize Workwin up in Minnesota. I'm sure you guys have talked to them. I think I've actually listened to the podcast you had with Jason.
Yeah.
But we sent it up to Jason over at Workwin, and we just kind of use them to cross check and validate the stuff that we have in house. They have a clippal system. We don't have a clippal system. We have essentially everything but a clippal system: Soundcheck, Clio, all the big ones. And so we really want to be able to validate and cross check what we see here with what they're seeing. So just so we know that we can audit our testing capabilities, and also know what our driver is best suited for. So one thing that's really nice about our drivers, we do have a 28 hertz resonant frequency, which actually in a closed box design, when designed correctly, we can get a resonance up to 50 hertz. So, and that's what we were kind of shooting for in the beginning was a subwoofer application with a 50 hertz resonance with closed box. And that's just for our particular application, but we're not here to talk too much about that anyways.
Mm-hmm.
Yeah, I just want to expand. As
Sure.
Andy was saying, when thinking about a subwoofer and thinking about those musical applications, think about those low frequency applications, 50 hertz naturally is a really important frequency, as we all know. It's really impactful to music and music design. Movies, we know, get lower than that, but when focused for music, it sounds really good. It's a really natural sound, as Andy mentioned. The not a requirement of DSP to be able to get a good sound. DSP just is an enhancement, as we all know, if done correctly. And so just expanding on why there was that focus, we had Trulli really put music first and try to achieve that level through technology, like to achieve that clear and loud musical sound through that driver. So
All right.
Yep.
And so one other application I briefly wanted to talk about was a mid-bass application. So Jordan briefly mentioned in the beginning of the presentation about putting this in the front stage of your vehicle. Let's say if you have like a car door, how much kind of generally roughly how much airspace are you working with in a car door, and how thin can we actually make that. How close can we bring that back wall to the back of the driver before we start seeing weird stuff occur?
Mm-hmm.
So we were able to fit it into that's a 3.25 inch thick enclosure there, and I think it comes up to about 8 liters of internal volume. There is a brace that goes in between the back wall and the front wall to help it. And then we did line the back wall with a little bit of Dynamat. I'm sure some of you might know what Dynamat is, but essentially it's a very gummy sort of dampening substance or a sheet that goes on the back.
All right.
Commonly found in cars as you're upgrading your interior car speaker doors. You're going to apply some matting to the metal of the car to reduce the noise of the vehicle, but also keep the energy inside the vehicle. And so Andy here was trying to replicate without using a vehicle, because a vehicle creates a lot of other variables, but creating an enclosure similar to a door and then testing for the reproduction.
Okay.
Yeah, and we get a good mid-bass response from 40 all the way up to, I think, they're cutting off my side. I think that's 300 to 400, sorry. So fairly decent mid-bass response. That was kind of an extra. We were mainly designing this as a subwoofer first and foremost, but having a having a good mid-bass response is ideal as well, especially for car applications that rely on a mid-bass driver for down low in the door. And if we can give them more driver area, I mean, a 10-inch driver in a car door is not necessarily even possible nowadays, let alone, but now it is.
Right.
So, and we have switched. One other thing, it's not pictured here. This is actually with our copper clad coil, but when you switch the coil to aluminum, we do have an improved mid-range response. So everything from essentially 100 and above is increased by 1 or 2 dB. So, which is good. So,
all right.
Sweet.
Yeah.
And feel free to go beyond 5 minutes. I don't know why it's there, frankly, to be honest with you, but that's all the slides we had prepared for y'all today.
That's excellent.
So, one of the key things, I guess, is in terms of making a slim speaker. So how do you deal with the issue of X max? You mentioned it briefly. Is it inherently limited? How slim you want to go limits how much X max you can have? Is that kind of a mechanical limitation?
Yeah, yes, but it's not as dramatic as other driver manufacturers when it comes to X max differences. We can, it is essentially a one, not one-to-one. It's a direct relationship between how much depth you're willing to give up versus how much X max you actually want out of the driver. But I mean, it's pretty much, I think it's millimeter per millimeter. It's you get a millimeter out of the driver. You want to add a millimeter of depth. You get a millimeter of X max. It's pretty.
But your design is inherently like halving that because you don't stack the spider.
Sure.
Then you delete that gap, and then you have to have the depth within the magnet as well. So you actually. You get the same X max that a traditional setup would have for half the thickness of that part. Would that be true?
Yes, that's about true.
Yeah. And diaphragm then, do you have to use a flatter diaphragm?
We use a flat diaphragm. It's a foam sandwich. So there's a back skin and a front skin, and then there's a foam in between. We are in conversations with other suppliers we want to take more mass out of the diaphragm, just because we're not quite happy with the moving mass where it is right now. We wish it was a little bit lower, and so we're in talks with other suppliers to bring that down for future models. But the foaming process has worked for us, and we've been doing pretty good with it. The rigidness is really nice. It's very rigid and very good.
Is it fair to say that in low frequency drivers, bass, mid bass, it's not getting a big cone is not as critical as if you're trying to do a lot more high frequency stuff? Is that fair to say?
Yeah, that's definitely fair to say. Low frequencies are naturally more omnidirectional than high frequencies are. High frequencies don't require as much of an effort to keep them in the proper direction. So yeah, definitely.
And then so you have to go out and find somebody to manufacture these things. And the processes, is that end up quite significantly different to what people are doing with a traditional speaker? So they might have they've got you drop in the spider and put in a center and gauge glue and these type of things. You have to do things upside down, or is it?
So we do everything in house, and we've actually, I don't know. Can we bring up the presentation again? I don't know if it's possible. Right. So you can see these little gaps in the motor here. Essentially, we have like fingers that come up through the motor and help us align and center the coil in the motor. Okay. And then eventually those fingers slip out of there and you're able to take the whole thing off or whatever. It's very unconventional. I think I've seen how other manufacturers have done it, and they do it upside down, like you're talking about with the thin drivers, where the whole diaphragm assembly is down, and then they bring the motor down on top of the diaphragm assembly with the coil. And that's certainly compelling, but we found that this is worked for us. We've been able to be repeatable.
And this example you're showing is a 10-inch, effectively a 10-inch speaker.
Correct.
Yeah. And is there a benefit in having the relatively huge coil? I mean, there's pros and cons to that, or net benefit. So you mentioned about you get better heat dissipation. Do you not also get a much larger magnetic, like a BL? You've got a huge L.
It doesn't really work that way. The concentration, the concentration of wire in the gap is more what increases your BL factor than the actual length of wire radially, right? So you want to take like a cross section and see like, okay, the length is actually how long this is, right? How big, how much of a
vertical
in the gap you actually have. It's not actually horizontal. So it's actually it stays relatively the same versus a conventional driver, but we do have a lot more magnetic force due to the fact that we have 16 magnets that are 16 N52s, so the highest strength magnets that we can use.
Mm-hmm. That is a lot. And so then the concept, of course, you're going into boxes that are going to be very slim. And I think you mentioned briefly about how slim you could go before things start to go crazy. What ends up the limitation there? Do you need just enough space behind the driver to let that pressure escape?
Yeah, so we haven't seen too many bad. Really, what happens is the box fails before the actual driver fails, because the back wall itself has a little bit of flex in it, no matter what. So you got to do whatever you can, and that's what I was talking about with the Dynamat. Whatever you can to quiet down that back wall to make it sound good.
Right.
But you can't. One thing is, when conventional drivers, when you go to take TNS parameters, you can set the driver on the table. You can put a mic up to, or a laser up to mic, or a laser, whatever you use, up to it, and take the measurement, and you're done. That's a free air enough system to take that measurement. With ours, you can't necessarily do that. If you set it on the table, that kind of seals off the back. So you don't have as much surface area that's kind of in the free air domain.
Yep.
So that's one difference that we have is you can't get right up against the back wall of the enclosure. You need to have a little bit of space in order for that airflow to still, for that pressure to still.
Yep. Okay.
There. So.
They used to say do something like people would hang it by a wire or something to really get free air.
Yeah, and that's what you really need to do in order to get free air, because you're still going to get, even with conventional drivers, you're still going to get reflections from the table, right? They're coming back and messing up your small signal analysis.
Yep. And so starting off with the bass speaker, is that kind of trying to address the problem of huge subwoofers in a small space? Is that where there's a good opportunity?
Yeah. Yeah. So my background, so uniquely, I used to compete in DB drag, Mecca, Iasca, and so I used to have
so familiar with those
ginormous subwoofers, and so on the competing level, but then also in the pro audio level, the weight and enclosure requirements is just huge. And so while the trend has been getting shallower, they're still heavy and they're still not that shallow. And the ones that do get really shallow, in our experience, don't perform that well or don't perform that low. And so we are really proud that we're not compromising on the output, but really making an improvement to the requirements of enclosure, space, and weight.
And then, go ahead.
I was going to say, so you're one of those guys, like, what was it? DJ Magic Mike from Miami and his 16 hertz bass rap CDs. You'd be using those to trial out your stereo system in your car.
It was obnoxious. I'm not going to lie. But it was a lot of fun. I learned way more than I ever could have imagined. But it definitely gets you in trouble. That's for sure.
A lot of extra epoxy just to stop everything from vibrating out of its. So my enclosure was built with 3,200 pounds of concrete. Wow.
we cut the roof off the vehicle, poured it in, I was doing mid 160s on the Term Lab sealed at the dash. So I did not sit in the vehicle.
DBSPL.
Yeah, 163 DBSPL.
Yeah, no, that's instant hearing damage.
I was not in the vehicle.
By a long shot.
My head unit was on the external of the car, but those are the extreme cases, right? And there are still the hobbyists out there, and I love that world. Now I've kind of moved into the sound quality competitive side of the world and appreciate that side as well. But when looking at the OEM application, when looking at the true music lovers, just the music hobbyists, the weekend warriors, and everyone in between, music's a big part of your life. And so how can we improve that daily commute? How could a manufacturer or others think about that infotainment or that experience in car? And we think there's a lot of opportunity to reposition that experience leveraging this technology. It really just depends on what your output desires are. Is it space and weight and trying to improve the sound minimally, or is it you're trying to immersify the user and you have a little bit of weight to give up, or you have the power to drive the system? You just thinking about that ball of yarn and the variables that you have to pull. It's really just dependent on what your use cases are. There's no right or wrong.
All right.
I just want to quickly.
We're hoping.
Go ahead. Sorry, Andy.
Yeah, we're just hoping that this opens up a new opportunity for a whole bunch of people. Honestly, thin driver technology, we know that it can fit into a bunch of different spaces that it couldn't before. So having that is impressive.
Yeah. Just earlier in the presentation, you mentioned about scaling, and I think you mentioned 40 millimeter drivers. Curious a little bit about that. Happened to be playing with 40 millimeter drivers just recently, and
for sure.
Yeah,
it's a great question. So we do have one product that's in market today. If you went to our website, trulliaudio.com, and I don't mean to make this a plug, there's one product that we sell today, and it's called the Jam 5, and it has two 38 millimeter square drivers. So it's actually a square perimeter coil. There's a tweeter in there, two passive radiators, all inside 2 inches. It's tri-amped. It's really impressive. It'll take the Coke Pepsi challenge against any Bluetooth speaker in its price or size class. I do mean that, and I encourage others to do that. And so Andy could talk a little bit more about the driver itself, but that's the application that was originally put into today. And it's an incredibly good sounding package for being so small.
Yeah, exactly. That's a Bluetooth speaker application. And you might actually have a reasonable internal volume, but you don't necessarily specifically have depth where you want it.
Correct.
That's sort of an application. You might have a board, your board's covering right up behind the driver.
Right. So there's
actually a bit of volume there, but you just can't have space for the magnet to stick out the back.
So the enclosures are individual for the drivers. So the drivers and passives are in their own individually sealed enclosures, which is also different than a Bluetooth speaker traditionally. The boards are inside the battery chamber that's shared with the tweeter only. And the product is a Bluetooth speaker, but also a USB-C digital speaker. So if you plug it into your computer, it will be recognized as a USB-C device. And so then you'll take advantage of the higher fidelity transmission. And then the speaker really comes to life and even gets louder. So definitely recommend that use case for the content creators or music producers that are on the go, or maybe your speakers are only fair today and you're looking for something a little bit better on a smaller footprint.
All right. And your plan going forward, is there a time where you're going to scale manufacturing outside of are you looking to work with somebody like Workwin/Misco, or you're going to go offshore, or any kind of plans to expand your manufacturing base?
So today, right now, we're in just around 10,000 square feet. So we are not large enough to be able to scale and mass produce. But the engineers at Trulli all come from Fortune 500 backgrounds, specifically in high-end test and scaling. And so when thinking about how we move this into higher productions, as the needs become reality, we are definitely preparing ourselves for that transition. So as that need becomes a reality, I know Kurt says hi, and so our head of supply and operations, that's a big part of his avenue, and I wouldn't want to speak on his behalf, but I know that we're in preparation for the high demand.
Okay, no, it sounds exciting. I know this. I mean, I think Simon and I both. 2010, I was working for the British guys, NXT, trying to do flat speakers and thin profile, and Simon was somewhere else in the world selling slab sound or something like that. So, everybody's been working on this space. Nobody's really conquered it. So it's exciting to see somebody taking another shot at it, because it's always got demand.
We've got time for one more question.
Sure.
You mentioned flipping the speaker around to take advantage of the visual effect. Do you mean that you'll get same radiation front and back?
So we've tested it, and I just want to speak real quick, Andy. So in a SPL environment, or more of a low end subwoofer application, less musical requirements. I found a really good use for it when testing for that aesthetic side. On a technical side, I want to let Andy answer, but on a aesthetic, just low end frequency response, me and my old team, we had some fun with that and actually had some really surprising results. So look forward to doing more with others and trying to explore that.
Yeah, low frequencies, like I was talking about the omnidirectionality of it. Low frequencies, it doesn't matter nearly as much if you flip it around. The main reason you'd want to flip it around is if you want that more industrial look, or if your enclosure calls for it. That's how you would do it. But really, I would mainly stick to low or sub bass use cases for that. It wouldn't be necessarily ideal for a mid bass application, just because the directivity is not the same. It's
All right. Well, it sounds like we got it covered. So Jordan, Andy, thanks for joining us. And we encourage everybody, we'll put the links to their website below, and we'll also like, subscribe, share, everybody do all that good stuff for YouTube, Spotify, wherever you're watching this or listening. So thanks, everybody, and we'll see you on the next episode.
Thank you both.
All right. Take care, guys.